So look what we have here. A friend of mine was like, hey, I really want to see one of these blowing up, because there's all these videos on the internet going viral about them catching on fire, but nobody's really done any good tests about catching these stupid hoverboards on fire. And so we decided to go have these, and I found the cheapest and the worst one I could find, and oh my god, just look at the box. It was so horribly pixelated. It's like a 600 by 200 image? That's horrible. I'd say this is probably the most likely to blow up then. We got our charger, 42 volts, 2000 milliamps. Instruction manual. And there's the ugly thing itself. Oh god, that's actually quite heavy. Huh. Didn't think it would be that heavy. I rode one before that a friend had, but I wasn't too impressed by it. So what is all the hubbub about these? Well, they've been catching on fire quite often, more often than would be expected. And the main cause is the battery, which actually I would say most likely it's not just the battery, it's probably also the battery charging circuitry. Some people have actually had them catch on fire in the store without being used. Most have had the issues when charging. So evidently, the BMS does not stop charging the batteries, and so the batteries get charged to like 5 volts or whatever, or they don't have a balancing circuit. I'm not really sure. I don't think it would be a good idea to take it apart, because I want to try to get some interesting data on it before I take it apart. I have my thermal camera with me, and we can take thermal video of it to see how it's heating up, and if not, if I can't get it to explode, then I have a bunch of other stuff we can do with it. We can slowly ramp up the torture, like for instance, my mom's husband is like 300 pounds. We can have him drive it, and that'll be funny because he'll probably fall over a lot because his balance is terrible. But that'll be over the recommended weight limit. I can try to go up hills. I can maybe take him to my dad's house and drive in the cornfield, see how that goes. That'd just be a lot of falling. But I don't know if it'll get that far. This thing looks pretty fucking cheap. You know, I take that back. Not cheap. Cheaply made. Because like 350 fucking bucks for this thing, that's not cheap. This is still showing red, so it looks like it's still charging, but it should be good now. I mean, oh wow, they didn't even like fully tighten that connector. Okay, so there's a touch sensor underneath here. Interesting. I'm gonna kill myself with this thing probably. That's not too bad. Don't know how to do on the bricks though. Probably better not to film. It's not very easy on this ground because the wheels just continually slip. I think I just found a way to test it. Wow, that is a terrible design. Basically, it can roll. So, What the fuck is that? That's stupid. Going on concrete is actually pretty easy though. It's much nicer than on the muddy gravelly yard. Unfortunately though, whenever you jump off, usually it just starts rolling forward because there's nothing to stop it from just rolling downhill. That is such a stupid design. Wow. There's a little bit of smoke. Look at that. Looks like it's just the wheels though. Just the wheels smoking. You know what? I probably can't run down the battery in my backyard too easily. I'm gonna have to find a place where I can just ride this wide open as fast as possible. And yeah, if I do that, that'll probably take even more power than just grinding the wheels against bricks. But I don't want to do it in the main road because, well, frankly, I feel like a big idiot when I ride one of these. It's just so stupid looking. Gyroboards are just, I mean, they're definitely not the hoverboards from Back to the Future. I don't see how people can even like pretend they are. Well, that was kind of fun. So it doesn't really work too well on the ground, so that's unfortunate. Maybe I could just ride on the road and look like an idiot. My issue with this is that it's almost no better than walking, unless you're super lazy, which I'm not usually. I mean, whenever you go over speed, it starts beeping at you, but it's very faint. Oh, I can hear it. Dit, 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 dit. See, that's the issue. It's gonna roll all the way back down. Well, I almost got it down to a dead battery. It's flashing the green light. I assume that means dead. And I noticed that it's having a harder time keeping me upright. Oh, it's not happy. It's continually warning me now. So let's see if it even dies. Oh, wow. Whoa. That was a lot of speed there. What the fuck is going on? Well, I say let's charge it for a little bit longer. See how it goes. So I've come to my dad's farm for further testing of the gyroboard. Well, I went for a little swim in the puddles, so I really don't feel like riding it right now. It's just kind of boring. I was going to try and ride it on that road, but that'd just be boring. I mean, I don't think I can blow it up by doing that. So I found that trailer, and we have this trailer. I think I'll flip them upside down and use the wheels to make a dynamo, so we can have this hoverboard running in place at full power. You know, it's kind of hard to turn it off though. So here we're looking through my thermal camera, and you can see that the tires are heating up just a little bit from being operated. Now let's go around. I've added a few more tires, as you can see right there, just to help keep it down. Let's turn it on. And there it's going. That's going to heat up pretty quick, I think. That's going pretty low. Must have gotten overloaded. That's unfortunate. Switching to thermal camera now, we can see that, well, it is heated up a little bit at least. Let's look at the underside of it. Oh, wow, look at that. Let's see if it'll turn back on. Oh, no, it just flashed. I've gotten it to go into this state several times, and it just takes like an hour or two to come back to out of that state. It's kind of weird. Okay, so it's been sitting out here for, I'd say, 45 minutes or so. And let's see if it has reset to where it can turn back on now. Because I've killed it like this several times already. Too much load on it. Looks like the battery might be kind of dead. Be sure to be very stupid on, okay? Or actually, just be yourself. You idiot.
How do you get this? Alright, I'll do it. Go! Lean forward. Lean forward. Lean forward.
Here, do this. Oh, never mind.
Just jump on. How do you get off of it?
You step off.
Oh. Jesus Christ, Dwayne! That's not how you do it.
For your own safety, no more gyroboards for you. I cycle it on and off.
Why does it want to just take off? You're leaning.
Yeah, because you're leaning into it. Because like for instance, you can control it like that.
If you're moving forward at all,
yeah,
it's going to try to
you gotta try and stand on it just by itself. You can move around a little bit and stuff like that.
There you go. Look at the grass.
It can go on the ground. So yeah. So it survived one test, kind of in its stock configuration. Unfortunately, it's been a few days because, you know, Christmas happens, and it's been raining and whatever, so I've let it sit for a little bit. I let it charge up so it's fully charged, and we can do another test. But I say, let's take it apart before we do the next test. And maybe we can change the test a little bit. That'd probably be a good idea. So the first thing I noticed when I was taking this thing apart is that they didn't even drill that hole for the screw, so there was no screw there. And that screw looked like it fell out. So that's interesting, because that's all ripped out. So there was no screws there. But basically we have both covers taken off. we have the battery, which is here. Now, of course, this battery had all this plastic around it. So that's good. That's a nice amount of like layering on the outside. I'd wish for more, but whatever. And it had this like little arch holding the battery in that went underneath there. These wires connect up, these two connectors. So basically, we have the main hinge part here where all the wires can travel through. We have the battery right here, and it looks like this is the main like power supply unit. So that's interesting. That's the side that keeps getting pretty hot, at least on the other tests. So that's to be expected because it's a big heatsink right here. All these MOSFETs are connected to the bottom. And then on each side we have, it looks like the same exact motor controller. And I presume this probably has the gyroscope inside of it. What a piece of shit. So anyway, it's kind of interesting. I wasn't expecting these to be hub motors. But it looks like these are hub motors, just like, well, basically, this is a solid axle bolted on here. So like probably a brushless DC hub motor. So, similar to like the one on my electric bicycle. So that's pretty cool. Same for over here. Here's the main power connector for the battery, which is here. It's interesting that it actually uses the yellow, blue, and green wires just like my e-bike, which is kind of interesting because then it's like, well, I wonder if I could just use something like that to power my e-bike motor. It's kind of interesting. Looks like it's the same standardized connector between the power supply and gyroscope thing. Or if I could do something cool with e-bike motors, like 48 volt 1000 watt motors instead of just these dinky 250 watt ones, that would be crazy and scary. But anyway, let's go into the battery. Definitely going to take my gloves off for this one because I don't want to break anything. So this is the battery with the BMS. Just a normal BMS you can get from eBay. Very similar to the one I put on my electric bicycle battery. So that doesn't look too bad. Oddly enough, okay, so on these BMSs, they have the charge input, the power output, and the positive connector. So basically, it's kind of weird that they're not charging through the charge input. They're charging through the output of this, which is, I don't know if that's going to work or not, but it looks like it is. So whatever. But if that is, but that could be an issue. I mean, they're charging through the output of the battery, not through the input. The circuit is probably not expecting to be charged from that side. Oh, we got some models. ICR 18650. I believe ICR 18650 is normally a Samsung cell. Either way, these are most likely name brand cells, so that's good. Maybe they're just like low quality ones as they're binned. These are the ones that are like less quality. But still, they're probably better than most cells, so it looks like a good battery. And I don't have much to complain about the soldering job or the tack welding job. It all looks fine. I mean, it looks like barely a step up from homemade, but to be honest, it doesn't look like it's going to blow up. It looks fine. Now, the big question is it built big enough for the supposed 500 watts of power that is pulled from it? I would have to say no. I don't think that this battery I wouldn't feel comfortable pulling 500 watts of power from this battery pack. I wouldn't. But I don't think that Gyroboard is pulling 500 watts from this battery pack. Because the capacity on this battery is probably kind of a bullshit number. These are probably like the cheapest cells that they could buy that were still name brand. So these are probably ones that didn't come out as nice as like Samsung or whatever expected. So these are probably more like maybe 1600 to 2000 milliamp hours. And then the motors probably aren't actually 500 watts or 250 watts each. They're probably not pulling 500 watts of power. So the actual numbers, the actual specification of this and the actual specification of the motors probably will lead to shorter lifespan of the cells, but probably won't lead to fire. Well, at least with this battery, this setup. But likewise, the bullshit number of power of the gyroboard's motor plus the bullshit number of the battery packs is probably also not good, but it's okay. Thing is, though, a subscriber of mine named, oh, what was it? Jeff S. Kortlix. I don't know how to pronounce that. It's one of those things where it's like a license plate. It's probably easy to understand once you're informed of how to say it, but it's kind of hard to figure out. Either way, he took apart his gyroboard and found that it didn't even have 20 cells. On the sales receipt thing, on this like the specifications booklet that came with it, it said it had 20 cell battery pack, 10 series, 2 parallel, like this. Whenever you opened it up, the battery had like the plastic wrap like this one, and it had a sticker saying 10 series, 2 parallel, so it should be 20 cells in there. And when you opened it up, it was actually 10 cells. They cheaped out by giving half the cells. And whenever you divide your batteries in half, but keep the current draw the same, there's a very good chance that you're more than doubling the stress on the batteries. Likewise, if you double the battery size, you're more than halving the stress on the batteries, because, well, at least to a certain extent. Because, like, for instance, with my battery pack, whenever I went from like 9 amp hours to 24 amp hours, I noticed like a 4-time increase in range on my electric bicycle, because the cells were being stressed less, and so they were being more efficient and releasing less energy as heat, so they can go further. But if I were to make it a smaller battery pack, it would be less efficient and releasing even more energy as heat. And that's what we should end up doing. I think we should, or actually I think that I should, and then you guys can view, me cutting the traces on this, keeping it exactly the same, but cutting the traces on it, I'll have to figure out how, but cutting the traces on it so that this is, in effect, just a 10 series battery. No parallel. So it's only 10 cells that were actually being used. So then, I'll be like turning this battery, this nice, okay-ish battery, into one of the worst batteries that are actually kind of dangerous in this thing. And then we can do the test again and see if anything blows up. And there we go. Last connection broke. Okay, so it's 36 volts, yes. 4.4 amp hours? Not anymore. Now it's 2.2 at best. Nominal voltage 42, still the same. Nominal capacity 4.4? Nope. Structure 10 series 2 parallel. 10 series is correct now, but it's no longer 2 parallel. High quality 18650 cells? Well, I'll have to give it to them. They are name brand, I think, so yeah. They're as high a quality as you'd expect to get from this. They're higher quality than I expected, at least. So yeah, here we have our battery. So the battery will fit nicely back in here. Well, not nicely. It's a lot of pushing to get it in there. Not very good design, but I think there's just enough room right there to have a thermocouple coming out, so we can measure the temperature as it's being tested. Yeah, probably better. About there. I just realized whenever I pulled out this connector, it pulled out the entire connector housing except for the pins. That's scary, kind of. And there we have it, the fixed hoverboard, gyroboard, whatever, with, oh come on, thermal sensing capabilities. This is a, oh, what is this? Oh, a K-type thermocouple. Nice. So I say it's time for test number 2. Just the weather's a little bit different now. Since these are going to probably catch on fire, I'm not going to use my dad's good ratchet rope thingamajigs. So I went and bought my own that'll be a little nicer for this application. In other words, I won't mind if they catch on fire. Just some cheap, like $5 ones. These will be pretty good. And also they're quick connector too, compared to those stupid ratchety ones. Because with those ratchet ones, it takes me a good couple minutes just to get them apart, whereas these ones, you just press in and it'll be done. So I have the thermocouple hooked up now, and yep, K-type. Let's go with Celsius. It's a shame it doesn't go any lower. 3.8 C, nice. There's the gyro board. You can barely even make it out because it's pretty much the same temperature as the outside. But I say if we turn it on for a little bit, we'll definitely notice an increase in heat, especially on the tires, because those tires will be warming up due to the flexing of the rubber. Temperature is still lowering. Well, I say let's turn it on and let it go. Oh, it's so scary. That's weird. It sounds different all of a sudden. That's pretty fascinating. Oh, warming up. Looks like you just killed the battery, that's all. Well, hey, at least it didn't blow up. That's good, I guess. I mean, I want it to blow up, but... There's the thermal signature of it, I guess you could call that. That's the battery side. That's the motor controller side. It's not too bad. Oh, the temperature is still rising? Nice.
It was on 1.6, now it's on 117.2.
Okay. Oh yeah, you're right, it is still going. So it looks like the case is losing more screws. They just keep popping out. And the case is actually coming apart, so that's kind of scary. This is pretty bad design for the case. Still works okay-ish though. It seems to have less power now that the battery is half as big. But it's okay. I think next we should take out the BMS and we should stop using the 36 volt charger and we should start using the 70 volt charger that I happen to have laying around. This should charge at 2.5 amps and charge each cell to 7 volts. Or actually, it'll just charge till it blows up. Also got some of this house wiring. I figure I'll hook that onto there, and that should be good. It should be thick enough. Well, that's trying it for you. Positive and negative are both red. But I get to keep the BMS, so I think I'll rip the BMS connector off so I can keep that. Could use that for something else. See, this is how I thought the battery would come. But stop your laughing. It's just got to go back together until I blow it up. Just not blow up on myself, so yeah. Oh. I don't even know if this is going to go back together now. Oh, there we go. Well, that's about as far as that's going to go. So we're now all connected up, and we have charger, multimeter. The multimeter will only stay on for like 10 minutes though till it times out, so that's unfortunate. Kind of want to get it like, I'll have to turn it back on later on. But either way, it's at 39.9 volts now. Gonna do this. Now it's at 41.6. It's charging. And I'll sit in my city car. Acts as blast protection and wind protection. It's pretty windy outside. Let's see what the voltage is at. Whoa, 49. So that must be like 4.8 volts per cell. Holy shit. Okay, I'm getting out of here. Wow, it's actually at 55.7 volts now. I don't know if this is even going to go. Oh, and actually, as it turns out, for some reason I guess my charger was spazzing out. It does not go to 70 volts anymore. It goes to 55.7. So, I don't know. Right before I filmed the video before, it went to 70 volts. It's kind of weird. But yeah, this is not showing any signs of blowing up. So I hear you have, you can help me with a high velocity projectile.
Right here.
Okay. Just the battery's right there. Okay. So just kind of shoot wherever that is, you know.
That'll work.
Okay. I'll prop it up with a little piece of wood just to keep it from rolling around.
Ready?
Yep, I am ready.
Here we go. 3, 2.
Didn't have the battery in enough.
See, we got one more.
Yeah.
I also brought deer slugs.
Ooh.
Okay. Yeah, maybe try from this angle and try to...
You want to use a deer slug instead?
Yeah, I don't care, whatever.
It's a bigger.
3, 2. 2.
I would say that's pretty much the end of the test. Wouldn't you agree?
I say let's see if that thing can't take 3 more.
Okay, well whatever.
Rapid fire.
Well, whatever you want. I will not stop you. When I bought this thing, I was not expecting it to last through this. Come on up. Oh, fire. Yes! Yes! Oh my god. I've been wanting this for like 2 whole weeks.
Worth it.
Yes. Yeah. Whoa! Woo! That's... What the fuck? I guess it's not over yet.
I'm just waiting for that thing.
Oh yeah! Yeah!
Calm down, Daddy. You're gonna have a heart attack.
That is awesome.
Smells like lithium.
Oh my god. Oh my god.
These are 18650 cells. Wow. It's still not done. Whoa. I'm glad I did this out here, not in your shed.
Yes.
Yes. Try to ride it now. Try to ride it.
Don't pull to the left.
It's hissing at me.
It don't like you. Oh yeah, wow, that... Oh. Yeah. That one's still hissing. You get the water bottle? Thanks. I meant this for batteries, but I guess it'll work. Oh my god, all the shrapnel.
Yes.
That's pretty hot. I don't like that. Okay. I'm not really happy with that. I'll probably keep the parts and make a teardown video. What?
You gonna just leave it out here tonight?
Yep. I do not want to take that into any building.
No.
But to be honest, the rest of this part has the motor controller for this side, and actually no, the motor controller for both sides and this motor looks still fine. And the battery made sure to remove itself from the situation. So lithium everywhere. Oh! It's a lithium shell! After it popped out.
There's one too.
I think that one's full. Oh no, that one is empty.
Because I picked it up with this corn stuff. It was too freaking hot.
Those, on the other hand, those are still full. You know, this motor might actually still work. Oh well, it's kind of pointless, but oh well. Well, I would say good shooting, and I really don't know what else to say. I think that pretty much wraps it up.
We cleared them all out. That's
Yeah, yeah.
empty.
You did a pretty good job. I think that's pretty much it.
It was a good day.
Yeah, that was a really good day. Hope you guys enjoyed this video, and thanks for watching. See ya!